This video will summarize the absolute value function and the square root function. The absolute value function, the parent function, is f of x is equal to the absolute value of x. So I just generated some points here. If you plug in a negative to an absolute value, it's going to come out as a positive. So if you put in a -6, you'll get a 6. -4, you'll get a 4, and so on and so on. Now, you didn't have to use the same numbers that I have, so don't erase and make your graph or make your table look like mine. So if you were to plot these points, you would get something like this. So I'm going to use, make a line. So this is what the basic absolute value function looks like. It's just a V. So you'll need to know that an absolute value function, when you graph it, it's always going to be a V shape. The domain for any absolute value function is going to be all reals. And again, you can always write all reals as -infinity to +infinity. The range is not going to be all reals because if you can see here, this is the lowest point of the graphs, the vertex per se, and that point is 0, 0. So since the y value is 0 and it doesn't have any y values below that, you would say the range is from 0 to +infinity. Another way to write that is to simply say that y is greater than or equal to 0. For our example over here, we've got f of x equals x, the absolute value of x minus 4. And I've just got some points over here that I'm going to plug in, -4, -2, 0, 2, 4, 6, 8, and 10. Now, when you plug in -4 here, -4 minus 4, I just want to make sure you guys understand this. You have to actually perform this operation before you take the absolute value of the -4. So you have to actually do -4 minus 4 is -8. And then the absolute value of -8 is 8. So that is how you get out an 8. Some people make a mistake and they think, oh, well, I'm going to plug in a -4, but that's really a +4. So 4 minus 4 is 0. But just be careful when you're generating your table. I'm just going to quickly write down what all the numbers were that I got. So this one starts off at, as far as the vertex goes, I'll just go ahead, 1, 2, 3. And we'll go ahead and make this. So a table is a really good way to generate this one graph. Sometimes students have trouble figuring out where this point is, but basically if you just keep plugging in numbers, you'll eventually figure out where your line, your other part of your V is going to go. But you can notice that it shifted 4 to the right. Whoops, didn't mean to do that. So since it shifted 4 to the right, if you look in here, see how it's got absolute value of x minus 4? If the number is in, so the range of this one, you have to look at the vertex, and it's 4, 0. So the range of this one would still be 0 to +infinity, or you could write y is greater than or equal to 0. For this example, I used these x values. So when you plug in -3, you're going to get out a 6. You plug in -2 is 4. -1 is 2. And so on and so on. So when you plot these points, you'll realize that the graph is going to be just a little bit more narrow. So we'll go ahead and make those two graphs. And the reason why it gets more narrow is because of the 2. So it's kind of like having a slope of 2. So you go up 2 and over 1. The domain, again, is still going to be all reals. And the range, again, you look at your little vertex point, which is 0, 0. So the y values start at 0 and they continue to go up. So this one is still 0 to negative to positive infinity. Or you could write y is greater than or equal to 0. For the next one, the absolute value of x and then plus 3 is not inside of the absolute value. So the ordered pairs that you get for this are negative 3, 6, negative 2, 5, negative 1, 4, 0, 3, 1, 4, 2, 5, 3, 6, and 4, 7. So this one's actually going to start up here at 0, 3. So you get a few points. And connect the dots. And again, the domain for this one is all reals. But the range for this one, notice that this point here is 0, 3. So the y values don't start till 3. So the range would be 3 to positive infinity. Or you could write y is greater than or equal to 3. So in summary, what you need to know for this is the graph of an absolute value is always going to be a V shape. So graph is always a V shape. And to graph it, you want to create a table of values. And make sure when you do have your table of values that you include positive and negative x's. You also may want to take note of how it transforms. If there's a number outside of the absolute value, then that's going to move the absolute value of the graph of it, the V shape. It's going to move it up or it's going to move it down. Of course, if it's positive, that's why it moved up. If there is a number inside, then that's going to shift it either right or left, and it's the opposite of what you think. So this one was shifted right. And the only other thing I would make note of is if there's a number in front like this, that changes the shape. So a number up front, this makes it narrow. And finally, we have the square root function. The parent function for the square root function is f of x equals the square root of x. This function is probably new because you probably didn't ever discuss it in Algebra 1, and definitely not geometry. But notice my table here. The reason I chose these values is you really only need to know these 4 points because you're trying to figure out a number that's a perfect square, because you really don't want to put in numbers that aren't perfect squares because you'll get decimals. So if you put in a 0, you get out a 0. If you put in a 1, you get out a 1 because the square root of 1 is 1. If you put in a 4, you get out a 2 because the square root of 4 is 2. And if you put in a 9, you're going to get out a 3 because the square root of 9 is 3. So this will give you a nice little shape, and it looks basically like a parabola except it's on its side. So it looks like a sideways parabola. Now you can put in other numbers like 2 and 7, but if you put in a 2, you would get out, let's see, a 1.4. And if you put in a 7, you would get out about a 2.6. So if you go over 2 and up 1.4, if you go over 7, and then you go up 2.6. So that's why I don't like to put in numbers that aren't perfect squares. But anyways, you get a little graph like this. Your domain is going to be from 0 to infinity. And the reason why is because the starting point is 0, 0. So the x value is 0, y value is 0. So the domain is x is greater than or equal to 0. And the range for this one happens to be the same thing because the y value is 0. So the range is y is greater than or equal to 0. For this one over here, we'll do pretty much the same thing, just use these points. So here are the order pairs I came up with for the second example. So if you put in a 0, you get -3. If you put in 1, you get -2. If you put in a 4, you get -1. If you put in a 9, you get 0. And I don't have enough room to go over to 16, so this is what your shape looks like. And you can see that it's just been shifted down. It's just been shifted down 3. So you can see that it's pretty much the same thing, but it's just been shifted down. It's been shifted down 3 units. So this starting point now is 0, -3. So our domain is still starting at 0, from 0 to positive infinity, or you could write x is greater than or equal to 0. Now our y values, since we don't have any y values below -3, they start at -3 and go up. Our range is going to be from -3 to infinity. Or you could write y is greater than or equal to -3. For our next example, it's 2 square root of x. So I chose these numbers, pretty much the same ones that I always choose. So you put in a 0, it's still going to come out to be 0. If you put in a 1, the square root of 1 is 1, but if you have to multiply it by 2, you get 2. If you put in a 4, you'll get the square root of 4, which is 2 times 2, which is 4. And then the pattern kind of continues. Square root of 9 is 3. 3 times 2 is 6. And we won't have room for the 16, but square root of 16 is 4, and 4 times 2 is 8. So you could kind of see the shape is going to change. See how it's not quite as flat? So it's going to look roughly something like this. So this number in here affects the shape of it. So remember how we had compressed graphs and we had stretched graphs? So this would be like a compression, but it would be horizontally. The domain is still going to be all reals for this. I'm sorry, my bad. Not all reals. This one, it starts at 0, 0. So the domain for this one is going to be from 0 to positive infinity. And I should use a bracket here, not a parentheses. And the reason why I use a bracket is because the 0 is included, because x can be 0. And then the range would also be 0 to infinity. And again, if you don't like the interval notation, you can simply say x is greater than or equal to 0, and y is greater than or equal to 0. For the next one, our square root function here, we've got, you plug in a -1, and the reason why I started with -1 is because I knew -1 plus 1 was 0, and the square root of 0 is 0. So this graph is actually going to start over here. If you plug in a 0, you will get a 1. If you plug in a 3, you're going to get 2. If you plug in an 8, you're going to get 3. And if you plug in 15, you're going to get 4. And of course, we won't have the room to do this point, but so -1, 0, 0, 1, 3, 2, and then 8, 3. So this is what your graph looks like. So basically, it's just like the parent function. It hadn't changed shapes like this one, but it's been shifted to the left 1. So that number inside made it shift left 1. So if you have a number underneath the radical, just like with the absolute value, it's going to shift it either right or left, opposite of what you think. And the domain for this one, since that point is -1, 0, the domain starts at the x value of -1. So you would say it's from -1 to positive infinity. And then the range, that y value is 0, so it would be 0 to positive infinity. And of course, you can write it as x is greater than or equal to -1, or y is greater than or equal to 0. As far as a summary for this one goes, just remember that basically the graph of this is, it's half of a parabola, basically. So graph is half of a parabola on its side. And the equation itself has to have a square root, just like the absolute value equation has to have an absolute value symbol. And when you create a table of values, make sure you don't ever create a value that will be negative, because if you do, you'd have i's, and we don't have i's, because this is the real number system. So use x values in your table that are, well, I should say that will produce positive values.